Today I'm going to review an old exam because I found that really the best way to learn material is to read material and then take an old exam and analyze that exam. I always say you can take a multiple choice test and turn it into a true-false test, and if it's a true-false test, you can actually determine why the question is true or why the question is false. So let's see. Let's take a look at question number 1. It says bone. What does bone do? Well, let's try and analyze it. Does it provide support for muscle and soft tissues? Well, that's true. It says it's from the same germ layer as muscle. You have to realize that bone comes from mesoderm. And mesoderm is going to comprise bone and muscle and cartilage and all connective tissue. And so is from the same germ layer as muscle? Well, bone and muscle are both that, so that's absolutely true. It works with striated involuntary muscle to provide movement. Remember, there's 3 types of muscle. You've got smooth muscle, you've got skeletal muscle, which is striated voluntary, and then you've got cardiac muscle. Well, obviously, bone doesn't control my heart, so therefore C has to be false, so the only right answer that actually works there is A and B. Is there anyone else that's a kind of a good question you want me to take a look at here by chance?
Let's see 3.
How about 3? All right, so this is a really important question. And the reason being because it says how bone differs. You always want to look at a test and say, what is it really asking? It's not saying how is something the same, but how does it differ? Well, A says cartilage is vascular and bone is avascular. Well, let's see. Cartilage has no blood supply, so that's got to be false. It says bone is vascular and cartilage is avascular. Okay? And so therefore that's true. It says bone is from mesoderm and cartilage is from endoderm. Well, that's false. And then it says cartilage is from the germ layer of blood. Well, let's see. We said cartilage is from the germ layer of blood, and blood, of course, is mesoderm because it's connective tissue. And bone is from the germ layer of muscle, and of course, it's from the germ layer of muscle, so that's true. But if you looked at that question, you'd say, well, then the answer must be what? Well, you'd say it must be B and D. But remember, that's just telling you how it's the same. Question D, answer D, is really answering why it's the same, not how it differs. So therefore, that's why it cannot be the right answer. And the answer has to be B. That's the only true statement there, just because that one word. Let's take a look at question number 4, for example, the pubic symphysis. Well, again, it's asking you to identify where it really is. We know the pubic symphysis joins the pubic bones, which are the 2 bones that come together that join the pelvic girdle. So let's see, it resembles the atlantoaxial joint. Well, the atlantoaxial joint, remember, that's a diarthrotic joint. Well, the diarthrotic joint, atlantoaxial joint, that allows me to rotate my head. That's freely movable. I certainly can't move my pubic bones like that, so that's absolutely a false answer there. The next one says it's a slightly movable joint, which is true. It's true because that's used for childbirth. It resembles a joint between C3 and C4. Remember, C3 and C4 are amphiarthrotic joints, so that's true. It's immovable in men. No, remember, it's a slightly movable joint in men, but again, it's only for childbirth in women, but that's certainly false. And so for the answer can only be B and C. So there's your answer, B and C.
Let me see 6.
How about number 6? Number 6 says the axial skeleton. Well, kind of think, axial skeleton is my axis. So if I'm looking at this skeleton right here, just really briefly, and you probably can see it well enough, and you can always look in your book at it, but just kind of think that...
It doesn't look like he's cooperating.
Really. He's not cooperating. I don't think he likes me. But anyway, my axis, he doesn't even like to turn his head.
No.
He's camera shy. His axis is actually coming down from here, so it's my skull, it's my sternum, it's my ribs, it's my vertebral column. But the rest of these bones here, like my clavicle, like my scapula back here, like my humerus, anything down below here are appendages. So we're really looking at this question is, where does the axial skeleton, which is obviously up here, which is obviously here, so looking at my friend here, where my axial skeleton articulates superiorly with the appendicular, well, this is superior, this is appendicular, so it's got to be right here. If this is the sternum and this is the clavicle, let's look for that answer. And sure enough, number 6 says at the sternoclavicular joint, so that is the right answer. Sacroiliac joint, that would be if I was talking about the inferior articulation. Any other question that you want me to take a look at?
Let me see 10.
That's 10. Fine. Let's see endochondral ossification. So let's take a look at 10 here. Endochondral. Remember, endochondral means inside cartilage. Inside a cartilage model. So let's kind of think about that, inside a cartilage model. Well, it says it's where cartilage is replaced by bone. That's actually true. That's a true statement. Is where cartilage turns into bone. Remember, that's always false. Cartilage can never turn into bone. Cartilage can only be replaced by bone. Occurs in membrane bone. No, remember, that's going to be false because that's intramembranous. Occurs in the femur. Well, you know, the femur is a long bone, so therefore most of the bones in the body are endochondral, so that's a true statement, so there's your answer, A and D. Let's just look at 12, I guess, while we're at it. Number 12, osteon. You know, the osteon is something that is really important to understand, and I've drawn it before, and you can look in the book at very simply just by drawing a couple concentric ring circles. But each one of these is considered to be an osteon. So that's an osteon, and that's an osteon. And now it says it's the functional unit of not cancellous bone, but it's a compact bone. So therefore that's false. So it can't be A. The next one says that it's called the Haversian canal. Well, no, that's the Haversian canal. It's called the Haversian system. So that's got to be false.
Can you move the page a little bit?
It says it contains open spaces called lamellae. Well, lamellae are layers, like when you think of the word laminated. Well, these are layers. So open spaces are these things here. So that's not lamellae. They're actually called lacunae. And so that's false. It says it's found in both compact and cancellous bone. And again, that's also false because it's not found in cancellous bone. So therefore, none of the above. Students oftentimes have a tough time answering a question, none of the above. They think there's always got to be a right answer there. And the answer is that's not always true. How about...
let me see 17.
17, okay. Well, if you kind of think back just for a second, if I'm looking inside of the cranial vault, remember this is the sphenoid bone, or the butterfly or bat-shaped bone. This is the sella turcica here, and this is where the pituitary would be sitting. So actually right here at the tip of my pen would be the pituitary, or something called the hypophysis. So let's see. The question says, is the neurohypophysis located in the sella turcica? Well, the answer is true, right? It's in the sella turcica, because remember, if this is that cranial vault, and this is the sphenoid bone coming down, this is the sella turcica, and the neurohypophysis is nothing more than the posterior pituitaries. And so therefore, it says it's located posterior to the sphenoid bone. No, it's part of the sphenoid bone. It's called the anterior pituitary. No, it's called the posterior pituitary. So that's false. It's anterior to the ethmoid bone. Well, that's up here. So it's not anterior to the ethmoid bone, it'll be posterior. So therefore, that's why the only correct answer there would be A. Anything else that you told me you were taking a look at this exam?
Let me see. Let me check out gout. I guess the next one down.
Gout. Okay. Well, gout, probably most of you have heard about. I always think of gout, it's the military. The military go fishing on the weekend. When they go fishing, they drink a bunch of beer. Beer has purines and pyrimidines in it, and therefore they drink all this beer and they wake up Monday morning with a toe the size of an elephant, and therefore generally it goes to the big toe. And so therefore it's asking what gout actually is. Well, gout is a what? Well, gout is an inflammation of the big toe, and so therefore, but it doesn't just affect the big toe. So is it a synovial inflammation? Absolutely true. It is a synovial inflammation. Is it caused by sodium urate crystals in the joints? And of course it's caused by uric acid in the joints, so that's true. Because sodium urate could also be called uric acid. Only affects the hallux? No, it could affect any of the bones of the foot, any of the bones of the hand, but generally the most common presentation is the hallux, but not only, so that's false. It's certainly not sodium acetate again, because we said it's urate, so the answer is A and B. As I was looking through the exam, I noticed that question number, 32 is one that would be worth taking a look at. So let's take a look at 32. Let's take a look at 24 while we're at it. 24 says the 3 monosaccharides. Remember monosaccharides, when you read the book and saw the chemistry in that, you saw that monosaccharides are C6H12O6. And there's only 3 monosaccharides. There's glucose, there's fructose, and there's galactose.
Can you move the page just to your left a little bit?
All of those are all the monosaccharides we have in the body. This is the number one source of energy in the body. Fructose is one that we're always going to see in basic, it's what's needed by the mitochondria in the sperm. And so therefore, these are the 3 monosaccharides. So let's see. Table sugar is a disaccharide. That's sucrose. So since sucrose and table sugar are the same thing, because that's a di, that's false and that's false. The 3 monosaccharides include glucose. That's true. Not maltose. That's false. Not lactose, because that's milk sugar. False. So the only right answer is glucose. So just remember, C6H12O6, that's my 3 monosaccharides, glucose, fructose, and galactose. Think of table sugar as being a disaccharide. Remember, di is going to be C11, H20, it's C12, C12, H22, O11. So remember, that's the difference between a mono and a disaccharide. Always think of that as the word sucrose. What's another one we could really take a look at?
You were going to show me 32.
32, it says the cristagalli is a process of the sphenoid bone. Well, again, if we're looking inside of this cranial vault, I can see right here, this is the frontal bone, this is the ethmoid bone. There's 2 processes of the ethmoid bone. There's the cristagalli and the cribriform plate. The cribriform plate is what actually comes back down into the top of the nose and forms a perpendicular plate, or it forms the superior portion of the nasal septum. So when I look at this question, and the question says that the cristagalli is a process of the sphenoid bone, it's not a process of the sphenoid bone, it's a process of the ethmoid bone. So therefore, that's false. While we're there, how about we take a look at 33? It says the perpendicular plate is the upper portion of nasal septum. Well, again, as I look inside of my nose, I know there's a bone at the top coming down, that's ethmoid. I know there's a bone in the middle here called the vomer, and I know down here it's going to come up with the 2 maxilla. So 1, 2, 3, 4 bones. And so therefore, that perpendicular plate, if I was to draw this really simply here, and just say, here's my nose, here's my nasal septum, this up here is going to be my perpendicular plate. This is going to be the vomer. And this back here, at the bottom, that's going to be the 2 maxilla. And so therefore 1, 2, 3, 4 bones, and therefore it is the upper portion of the nasal septum, so that's a true statement. Any other questions that you want to take a look at?
I was looking at 38.
How about 38? So if we take a look at 38, it says, when I stand on my head, my nose is inferior to my pelvis. That can really be confusing to people. Just remember that there's something called the anatomical position. In the anatomical position, remember, I'm standing erect, my palms are facing forward, my plantar surface is facing forward, so in effect I'm dorsiflexing. Okay, so that sort of changes things around. When we start getting to the muscles, it's going to show why the muscles are called anterior and posterior, and their flexors and extenders are on opposite sides as far as anatomical position. So when you're talking about, whenever you discuss where something is located, you always consider the anatomical position. So it says my nose is inferior to my pelvis. Well, let's see. My nose is superior to my pelvis. But this says when I stand on my head. Well, that's fine that you said I'm standing on my head, but I always describe something as in the anatomical position. So therefore that is false. So even though as you're reading it, you're thinking, well, wait a minute, that's true if I was standing on my head. But if you were to look at any type of autopsy, if someone was found hanging, you would always describe them as if they were upright. So it doesn't matter. If someone was hanging from their feet, you still would to describe the body or any injuries to the body as if they were standing upright. Same as if they were laying down or in a prone position. Let's take a look at maybe question, is there another one you want to look at? Maybe 35?
Yeah, go back to
35.
Yeah.
The mylar bone contains the zygomatic arch. Well, again, this shows you why when you take a test, whenever you're looking at medical records, how critical words are. There's no such thing as the mylar. There's something called the malar bone. So the malar bone, it says, contains a zygomatic arch. So remember, this is the, first of all, to tell you what this is my malar bone or cheekbone right here. This is my zygomatic arch right here, and this is my temporal bone. So that question's wrong in two perspectives. One, there's no such thing as the mylar, it's the malar. But number two, the zygomatic arch is actually a process of the temporal bone. So to really fix this, should say the malar bone contains a zygomatic arch. That's false. It's really the temporal bone. So there is no malar, but really it's the temporal bone that's going to contain the zygomatic arch. That's the one that's oftentimes broken in, for example, a car accident when someone hits the steering wheel or someone punches really hard on the side of the face. What's another one we could take a look at?
Let's take a look at number 45.
45. So if we go to 45, and remember, I'm going to be sending you a copy of this old exam before you take the exams, so you'll have time to analyze each question like I do, and you'll see that's how I base my tests off of old exams. 45 says there's 3 germ layers from all tissues and organs and blood forms. Remember, a real simple way I could say, gee, I could really teach this whole course to do with embryology by saying I have 3 germ layers. I've got ectoderm. Remember, ectoderm is going to be nervous tissue. It's going to be the lens, and it's going to be the epidermis. There's also something called mesoderm. I talked about that a few minutes ago. Remember, mesoderm is going to be bone and blood and muscle and cartilage, all connective tissue. And then finally, I've got endoderm. And endoderm is going to be viscera, and it's going to be, another way you could say it for the endoderm would be guts or glands. And those are pretty much generalities, but basically when this says there's 3 germ layers from which everything arises, and therefore that's true. Everything can come from 1 or 2 or 3 of these germ layers combined together. And as we move on in the course, we'll see how, for example, when we look at the gut, how the 3 layers of the gut, you've got that internal layer, which is going to be gut, so therefore that's going to be endoderm. But then below that inner layer, that viscous layer that's got the mucus layer, the muscularis mucosa, I'm going to have muscle, and muscle is going to be mesoderm, and that'll be important when we start talking about how cancers can spread if they're not diagnosed quickly. Is there any other I'm going to take a look at here? Maybe 48?
Yeah.
Okay,
yeah,
let's look at 48. There's a question I can see that students can get a mistake on very easily. Why? They read too fast. The first thing you want to say to yourself is memorize the carpal bones, memorize the tarsal bones. If you look inside of your textbook, you'll see there's mnemonics in the back that there's some that are real important to know, like the carpal bones and the tarsal bones. I know there's a trapezium, I know there's a trapezoid, and I know that there's no such thing as a lunatic, but there's something called a lunate. So therefore that really should be the lunate, or moon-shaped, and therefore that makes that false.
I know a few lunatics.
Okay, I do too.
Okay.
I might be one of them at times. I know this guy right next to me right here is.
That's true.
He doesn't pay any attention.
No.
Did you notice where his head's facing? He's not even facing the screen. He won't even look at me. How about 52?
Sure.
52 says the sex cells, okay? Well, let's think about sex cells and that. We know that there's something called a sperm, which has got 23 chromosomes, which is called a haploid cell, which is called an end cell. And then we've got an ova, and an ova is got 23, and it's also haploid, and it's also an end cell. And when the two of them get together, it equals a zygote. And the zygote is got 46, or diploid. Or it's called the 2N. So the sex cells, let's see, are haploid cells. Well, we know they're haploid cells, so that's true. They're called the gametes. We know they're called gametes. That's true. They're diploid cells. No, they only got 23 chromosomes. That's false. B and C can't be right, so that's false. So the right answer there has to be A and B. So the right answer is they're haploid cells, and they're also called gametes. Any other ones we should maybe take a look at?
Let's take a look at number 57.
57. 57 says, yeah, that's a really good question. The reason being, again, if I could get my friend here to cooperate with me, but as I look at the ribs here, you notice that there's basically going to be different types of rib. There's true ribs, there's false ribs, and there's floating ribs. And if you notice that there's the sternum here, some of the ribs directly articulate with the sternum, some kind of piggyback off of those ribs, and some of those ribs, if you can kind of see where my finger is down here, if you notice these ribs here and this rib right here where my finger is touching, again, you can look in your book or you can go to your AP Reveal and see some great pictures of these, and you'll see that I'm going to have basically true ribs, false ribs, and floating ribs. So therefore, this question says, how many do I have? Well, I know the total number of ribs that I've got is going to be 12 pair. So it's basically 12 pair of ribs, or 24. But those are going to be broken down into basically true ribs, false ribs, and floating ribs. So therefore there's going to be 7 pair of true, and there's going to be 3 pair of false, and 2 pair of floating. And so therefore true ribs are going to be ribs that directly articulate with the sternum, and they're called vertebral sternal. And so therefore, if these ribs here with my friend here, how they're articulating, and you can see that only 7 pair are actually articulating directly with the sternum. These are piggybacking, these are floating, and so 7 times 2 is 14. So that's the right answer to that question. Any other ones?
Let's look 2 down, 59.
2 down to
the PTH.
PTH.
Yeah.
Good question there, because you have to realize that, remember, an osteoclast.
Ooh, move your page down
is
just a little bit.
An osteoclast is a bone eater. So it's going to eat away bone. And so therefore, when my body demands more serum calcium, I'm going to have 2 different glands that are going to produce hormones. I'm going to have the parathyroid gland, which are 4 little bumps basically on the base of the thyroid that are going to produce PTH, or parathyroid hormone, and they're going to increase the class. They're going to increase the class activity. The hormone that's antagonistic to it is going to come from the thyroid, and that's going to produce calcitonin, and that's going to lead to decreased class activity. So when it says parathyroid hormone stimulates osteoclastic activity, that's a true statement. So just kind of think, if a woman has too much PTH in her body, she's going to increase her osteoclastic activity, and she's going to get decreased bone density, which is going to be called osteoporosis or osteopenia, and that's what leads to why women need to have DEXA scans, and even men, they're finding out, have a lot more osteoporosis than we used to believe. How about
let's talk about the eyeball muscles.
Eyeball muscles are really an interesting topic too, because it says extrinsic and intrinsic muscles. When we get to muscles, we're going to talk about muscles that are inside. The origin and insertion action is going to be inside of a body part. And even though that's going into muscles right there, just remember, if something is extrinsic, the origin of the muscle is outside of the body part. I'm going to see that, for example, in the hand, I'm going to see that in the foot, and I'm going to see that in the eye. Intrinsic is the same thing. Intrinsic muscles are totally inside of the hand, like when I'm doing that. These muscles are totally inside of my hand. If I'm doing this and flexing, I can see the muscle is outside of my hand. That's an extrinsic muscle, that's an intrinsic muscle. So therefore, when we're talking about the eyeball, and the eyeball is going to have extrinsic and intrinsic. The extrinsic muscles we're going to learn, and it's going to be actually going to be 6 muscles in each eye, but those are skeletal muscles. I'm going to tell them what to do. And skeletal muscles are striated voluntary. Intrinsic muscles are the muscles that are going to focus my lens, and they're also going to close my pupil. And therefore, those are smooth. And since striated muscles are going to be skeletal muscles, the answer is that the intrinsic eyeballs are striated is false, because the only ones that are striated are going to be my extrinsic eyeball muscles. And as we move on with the semester, you'll see how quickly we're going to be able to memorize the 6 eyeball muscles by just saying something like, I've got a SR, superior rectus, and an IR, inferior rectus, and an LR, a lateral rectus, and an MR, a medial rectus, and an SO, a superior oblique, and an IO, and an inferior oblique. And then when we go to intrinsic muscles, we're going to just say something like the iris in this ciliary. How about 63? I think that's always
Yeah,
a
let's
good
do that.
question. Why is that so important? Because remember that this question is saying that there's only two pair of cranial nerves that are always CNS. Remember, central nervous system means that it's the brain, brainstem, spinal cord, CN1 and CN2. So how that really relates to this, if I had somehow my pituitary gland enlarged too much in a woman that was pregnant, it could actually sever the optic nerve and you can't regrow back a central nerve, so it's a permanent loss of vision. The same thing with CN2. CN2 is the ethmoid bone that passes through the nasal septum. Punch someone too hard in the nose, what's going to basically could happen, you could either kill them by breaking or hemorrhaging the circle of Willis, or what could happen is you'd sever that cranial nerve number 1, the olfactory nerve, and it's a permanent loss of sense or smell. So just remember, they start in the central and they end in the central. So there's only two pair that are always CNS, and that's true. That's going to be CN1 and CN2. The olfactory and the optic. Any other ones that are kind of
Let's take a look
interesting?
at 71.
71 says the ear canal is an opening in the mastoid bone. Again, it says here that this is the ear canal right here, 71.
Oh, move your.
And
I'm
it
only seeing your
says-
teeth.
There we go.
Yeah.
Okay, so here's my ear canal, okay, right there. So this is the ear canal. Remember, the ear canal is actually the external auditory meatus, and it says it's an opening in the mastoid bone. As a matter of fact, there is no such thing as the mastoid bone. There's a mastoid process. So this is the temporal bone. This is a process of the temporal bone called the mastoid process of the temporal bone. So therefore, when you have to answer these questions carefully, the ear canal is an opening, that's true. It's really called the external auditory meatus, so that's something you should know, but it's not in the mastoid bone, it's in the temporal bone. That mastoid process is nothing more than this structure here right behind your ear. And again, if you think about the significance of that, it's the air cells, and that's why children, before we had antibiotics and that, would have to have an incision and drainage and literally remove that process, or it could end up going to an encephalitis and a meningitis and eventually death of the child. How about we also take a look at any other ones that are kind of interesting
Let's
here.
take a look at 74.
74. Again, that's a good question again, because it's all to do with reading the question, reading the answer. So the question here says the total number of phalanges. Remember, phalanges are the bones that make up my fingers. And of course we're talking, and my toes. Well, remember the hallux is another name for the big toe or the great toe. The great toe has got how many? Just like my thumb. Since my thumb has only got 2, my hallux or my big toe's only got 2, and this is not talking about both of my halluxes with the halices, but this is in the hallux, and therefore the total number of phalanges found in the hallux is actually going to be 2. Okay, so just be careful when you're reading a question. If you said how many phalanges are found in both halluces, well, therefore together that's going to be 4. If you said to me how many are found in both of the pollex bones or the pollices, that's 4. But if you said the total number of bones in the pollex, that's just 2. So it's always remember reading exactly what the question is asking and what the answer is answering. Number 78, how about we take a look at that? The joint that allows for opposition. Remember, opposition is what calls the opposable thumb. When I take my thumb and I touch my little finger, that's called opposition. Well, when I'm doing that, if you notice, that joint is down here. When I do this with my fingers, those joints are right here. That's a metacarpal phalangeal, but this is a carpal metacarpal. So opposition is really a carpal metacarpal motion. So the joint that allows for opposition is a carpal metacarpal joint. That's really significant. So just remember, when you're moving your fingers, this is between my metacarpus and my phalanges, or a metacarpal phalangeal joint. When I'm doing that motion of opposition, where my thumb touches my little finger or my digit minimi, if you notice, that joint is right down in here. The reason I want you to know that, it's so significant when we have hand injuries. We fall on our hand and we break a couple of bones, and it's not a very simple surgery. And if left alone, you'll see that over time, the hand will literally just kind of turn into a claw's hand. Let's take a look at any other ones that you noticed.
82.
82. Okay, 82 is actually talking about the stratum lucidum. Well, remember, what we're talking about really here is the layers of the epidermis. Remember, they're all going to be stratum, so it's going to be stratum, which means layer. And therefore, I told you there's a mnemonic that Californians, so the way easy to remember is Californians like girls in string bikinis. You'll see that in every medical textbook for years. And if you look at the back of the book, you'll see in mnemonics, there might be a couple other ones. But if you just remember that mnemonic, remember that first letter of each of those, remember that's the stratum corneum, which is the hard layer that sloughs off when we wash our hands, the lucidum, which is the clear layer, the granulosum, which is a granular layer, the spinosum, which is spiny, and the B is basal or basal layer. That's where I'm going to have basal cell carcinoma, or the most common type of cancer. So now the question is asking, is working whether something's deep or superficial. Remember, superficial towards the top of something, deep is what's below it. So this question says, is the stratum lucidum, well, let's look at C, for example. Is the stratum lucidum deep to the corneum? Well, let's see. Here's the corneum. Here's the lucidum. It's deep to it. So we know that C is true. It says the stratum lucidum is superficial to it. No, that's false. Just the opposite. It says the stratum lucidum is deep to the stratum granulosum. Well, the lucidum is above it, so that's false. So therefore, the only one that works here has to be B. So the right answer there is going to, I'm sorry, is C. Excuse me.
Yeah.
Is C, is deep to the stratum corneum. So just remember, superficial towards the top of something, deep down below it, and just remember that mnemonic and you'll never get it wrong. And again, just remember, just like I said in germ layers, epidermis is actually what comes from the ectodermal germ layer, just like when we get squamous cell carcinomas. Next one that I think we could take a look at, maybe 85. 85 says the principal muscle of respiration. Well, again, it's just thinking very simply here that if I take the body here and draw a line between the two, and I have my lungs sitting up here, so this is my thorax up here, and this is my abdomen down here, and what separates the abdominal cavity from the thoracic cavity is the principal muscle of respiration, and that muscle is actually going to be the diaphragm. So therefore that means that that's a true statement. Any other questions you want to take a look at? Anything else? Let's just do one more here. It says a child usually has 20 gomphosis joints. remember I've got different types of joints, and just really quickly, remember I've got diarthrotic. Remember, di means fully movable. Most of the joints in the body are going to be fully movable. I've got amphiarthrotic, slightly. We talked about a lot of those when we talked about the vertebral column. Most of those are going to be slightly movable. Or if I said the pubic symphysis. Then I've got immovable. And that's synarthrotic. That's going to be like a suture. And then I've got this specialized type of joint that's between the tooth socket or the alveolus and the tooth itself by means of the periodontal ligament. And since a child has got 20 teeth, and they're called gomphosis joints, that means that's a true statement. And I think that really kind of gives you an idea on how to analyze the test. So before we take the first test, you'll get a copy of this. I think the best thing to do with it is take each of the questions, read the question, read each of the answers, analyze each of the answers, define what those answers are, and you can always get the right answer, and you could get 100% very easily. Anything else we need to do?
I got to study.
All right, well, let's start studying.
All right.
I'm not sure how this guy's going to do because he is not paying attention. I don't think I've even got a name for him anymore, but I'm just going to call him, he's taken the class too many times. I think he's bored. So have a great day. Thank you.
Take care.